ordinary level question based on complex numbers. Okay, again, fairly standard question. It'll come up every year. Two complex numbers, real and imaginary, given that W, which is just another complex number, is equal to U minus V, so it's 3 plus 2I, minus, and then I'll put V in there, close my brackets, minus 2. I suppose what they're testing there is that you know that the minus by a minus is a plus, and that a minus by a minus is a minus by a plus is a minus. That'll all break down into 3 plus 2I plus 1 minus I minus 2. This minus 2 in the end isn't affected by that minus on the bracket. I just put a little blue line under numbers and a green line under imaginary numbers, showing the examiner I know what I'm doing. 3 and 1 is 4, take away 2 is just 2, and the 2I minus 1I, it gives me just plus 1I, or plus I. So that's it. Part B, plot U, V and W on an Argand diagram. Argand diagram is just an axis, but for complex numbers they call it an Argand diagram. This is your real axis, which would commonly be called your x-axis, and your imaginary axis is your what would commonly be called your y-axis. So let's plot U. Use 3. We go 3 here and up 2, and we put a wee U there. V, we go out minus 1 on the real and then up 1. Put a wee dot instead of an X, and that's V. And then W we've worked out, that's 2 plus 1 is there. Okay, nice and straightforward. A and B are always pretty straightforward. C generally is where we'll run into a few problems. I'm just going to write down use 3 plus 2I. V is minus 1 plus I. And W is 2 plus I. So part C then generally has some sort of division of complex numbers. When we divide by a complex number, we have to multiply top and bottom by the complex conjugate of the bottom. Now, unfortunately, with complex numbers, that's either going to be something that you've revised and learned and know, or you're not going to be able to continue too far into the question. We need to add 2u plus a v, so it's 2 times whatever my u is plus my v. That's going to give me 6 plus 4i minus, that's a minus 1 there, sorry, minus 1 plus I. That's going to give me 5i plus 5. So the top line of that I can rewrite as 5i plus 5, and that's being divided by 2 plus I. We need to multiply top and bottom by the complex conjugate of the bottom. That is just the bottom complex number, but the sign is different in the middle. Okay. There's 4 steps of multiplication on the top, and there's 4 steps on the bottom as well. The top is going to give me 10i minus 5i squared plus 10 minus 5i. The bottom is going to give me 4 plus 2i minus 2i minus I squared. Somewhere at the top of the question, at the very top, it said I squared is equal to minus 1. So I'll just tidy up the top line a wee bit further. That's going to give me 10i minus the 5i. Okay, so that's going to be 5i plus 10 and then we've minus 5i squared. And on the bottom line, just to tidy it up, we're going to have the plus 2i and the minus 2i are going to cancel. The bottom of these complex conjugates is always the difference of two squares. If that makes sense, brilliant. If not, don't worry too much about it. And then we've got 4 minus I squared on the bottom. I'm going to bring in this I squared is equal to minus 1 now. And anywhere I see I squared, I can replace it with minus 1. So that's minus 5 times minus 1, which will be plus 5. And on the bottom, we're going to have 4 subtract, and that I squared is minus 1. That'll become plus 1. That's going to give me 5i plus 15 all over 5. That's a fairly good answer, but the examiner's probably looking for you just to tidy that up ever so slightly and leave it as I plus 3. All I've done there is divide in the 5 here and here. Okay, that's my answer. I probably want to put a wee red box around it or a red line around it to show the examiner that that's my answer.